All right, guys, so this is 9.1 Pythagorean theorem, and this only works for right triangles, and this is the famous one that we've all heard about before. So this is if you have like this value A, B, and C, you're always gonna know it adds up to this. So A squared plus B squared equals C squared. And then if you wanted to solve for the C value, you would combine like terms. So that, I mean, you would combine like the A squared plus B squared, and then you would take the square root of it. All right, A squared plus B squared equals C. And that will always equal this value right there once you take the square root, okay? So this is super important. It only works for right triangles, so you have to be aware of that. And that's about it. Oh, yeah, something I forgot to mention were the Pythagorean triples. So this is super important, so Pythagorean triples. And that just pretty much states that if, like, let's say the A value is 3, the B value is 4, you could always say, no matter what, that this C value right here is going to be 5. So this is a 3, 4, 5 triangle. And the other one that you kind of have to, like, that's also, like, super famous would be the 5, 12, and 13, okay? So just keep that in mind. These are two famous Pythagorean triples right here. And then just like small length, so A and B are pretty much interchangeable, as in like they can be any side length, but C is always opposite of the hypotenuse. So like this is your this is the right angle. So C is always opposite of that right angle, not the hypotenuse, my bad. So, and this is called the hypotenuse, if you had like a right triangle that was like this, and this, let's say this is the right angle, the hypotenuse would be this side. It's opposite, okay? So that's your hypotenuse. And then, I don't know, just kind of think of other ways. If you had something like this, and this was a right angle, then this side would be the hypotenuse, okay? These are just some scenarios. So hypotenuse is it's also the longest side always, guaranteed. So keep that in mind. All right, so example 1, we have A and B, and we have two triangles. Both of them are solving for X, but both of them are slightly different, so we'll do them both. So we have 5, 12, and we don't know what this X value is. So the first thing you have to do is you have to find out, is this the hypotenuse? Or is this X value the hypotenuse? Yes. Why do we know that? Because it's opposite of the right angle. So this is the right angle, and the opposite side would be this. So this is the hypotenuse. And we also know that this is what I just talked about, the 5, 12, 13 triangle. So I know X is equal to 13 right off the bat. All right. If you did want to do the math, we'll do it really quick. So it's going to be like 5 squared plus 12 squared is equal to this X value, right? Squared. So very quickly, 5 squared is 25, 12 squared is 144, and this is going to be equal to X squared. Combine like terms right here. So this is going to be 169 is equal to X squared. You have to take the square root, take the square root, take the square root. X is equal to 13. That's just a way for us to double check our work. But if you know it right off the, like if you know it, you don't have to do any of this. So just keep that in mind. Now, if you're looking at B, we have 7, X, and 14. So in this one, a lot of you guys might get tripped up, and you might be like, oh, this is A squared, this is B squared, and this is equal to C squared. But that would be wrong, okay? Because the hypotenuse is, so this is the right angle, so opposite of the right angle is this side length right here. So 14 is the hypotenuse. We know C is always equal to the hypotenuse. So it's going to be, in this case, it's going to be 7 squared plus X squared, right, is equal to 14 squared. All right. So you have to make sure that the hypotenuse is always going to be on this side that equals 2, okay? So 7 squared is what? 49. This x squared is going to be, we don't know, so it's going to be just leave as is, so plus x squared. And then 14 squared is 196. So I minus my 49 over, minus 49 over, and I get x squared is equal to the square root of 147. And then I have to simplify this, okay? So this is going to be, what perfect number goes into 147? That's going to be the square root of 49 times the square root of 3. It looks pretty yucky, but this is a 49 right here. Okay, the square root of 49 is 7. The square root of 3 is just going to be the square root of 3. So x is equal to, I forgot to do that, x is equal to 7 square root 3. Just to note, again, just to kind of remind, the hypotenuse is always the longest side length, okay? So if you were to put this in a calculator, 7 times the square root of 3, it's not going to be bigger than 14, okay? 13 is obviously bigger than 5 and 12, so just a reminder, heads up. All right, so guys, check it out. This is example 2, and again, we have A and B, and this time they're asking us, are these right triangles? So is A a right triangle? Is B a right triangle? So the cool part about the Pythagorean theorem is we can also prove right triangles using the a squared plus b squared equals c squared. So the side length A and the side length B don't really matter too much, but C has to be the hypotenuse every single time. So when you're setting these up, you have to remember that the hypotenuse is also the biggest side. So I know 8 is bigger than 7, and the square root of 113, well, I don't know exactly what that is, but if I had a calculator, it would be about 10 point something, right? Because I know the square root of 100 is 10, and the square root of 121 is 11. So I know it's greater than 10. I know 10 is bigger than 8 and 7, so this has to be my C value. This side length right here, from here to here, has to be my hypotenuse, okay? So when I set this up, it's going to be 8 squared. So we can call this A. So 8 squared plus, we'll call this guy B, which is going to be 7 squared, is going to be equal to my hypotenuse, which is the square root of 113 squared. All right, so 8 squared is 64, and I'm just going to use black. The 7 squared is going to be 49. And then the cool part about the square roots, and then when you square it, is that this cancels out pretty much. So this cancels out with this, so it's going to be 113. So 64 plus 49 is actually going to add up to 113 equals 113. So this is a right triangle. Right triangle. So we can add this little box over here. Okay? So yes, score. Now this one over here, this is, again, you kind of have to identify what's the right triangle, what isn't the right triangle. So if you wanted to come up with the number for this right here, it's going to be huge, right? So it's pretty much going to be 4 times 10, more or less. This is 95, so it's going to be bigger, right? So this right here, this one is going to be my hypotenuse. It also, like, literally looks like the hypotenuse, but you can't really go based off of look, so it is what it is. Anyways, so it's going to be, so 36 squared plus b squared, which is going to be, this is A, this is, we'll call this guy B, so 15 squared. Does it equal this? So 4 times the square root of 95 squared. All right, that's the big question right there. Now, 36 squared, I'll put an A just to kind of keep everything organized. So this is our A. 36 squared plus 36 squared is going to be 1296. Sorry, I need a calculator. 15 squared, that one's easy. That's going to be 225. Now, if you wanted to put this right here in a calculator, you kind of distribute the 2. So it applies to both the 4 and then the square root of 95. So the square root of 4 is going to be 16 times the square root of 95. Well, again, like I said over here, the square root cancels with the square. So square root, so it's going to be 16 times 95. And then we go from there. So we're going to combine like terms right here. And that's going to give us, I'm just going to use black right here. That's going to give us 1521. And does that equal 16 times 95? You'd put that in your calculator, and that gives you 1520. So no, it does not equal. So this is not a right triangle. So not right triangle. So not triangle, I guess. Or right triangle. My little box is right there. So it's not a right triangle. All right? All right, so like little notes, guys. So the classifying triangles. So if they were to ask you, how do you classify triangles? There's really only 3 types, right? There's acute, obtuse, and then right. Now the right triangle is what we've been discussing. And that's if a squared plus b squared equals c squared. Now if you had a triangle where it was something like this, or well, maybe this right here, this angle or this line right here was just a little bit inwards like that. So it wasn't quite right. So it's going to be A, B, and then this would be the C value. Because again, C is still the biggest. So if A squared plus B squared is greater than, right? Then C squared, then you know A squared plus B squared, then you know this is going to be an acute triangle, okay? So oppositely, if you had something like this, where like, oh man, that's a really ugly triangle, but it is what it is. So if you have A, B, and C, and this is clearly not a right triangle, right? This guy's just obviously obtuse. This angle right here is just huge. This is not a right angle. This is just a huge angle, greater than 90, right? So if I did, so if this C value, so A squared plus B squared is less than C squared, then this guy is always going to be obtuse. And that's it. So it's either going to be acute, right, when it equals, and then obtuse if it's like just like way greater than. All right. All right. So guys, check this out. This is the last example. And in this example, you're going to verify if it's like right, acute, or obtuse. All right. And the way, so we don't really know what it is yet. So the way we're going to go about this is, so we have the 3, 4, 6, right? So this, again, C always has to be the greatest value. So this is our C value. And then A and B, they don't really matter. As far as like, they can just be any side length. But the biggest side length always has to be C. So, again, I'll use my pens, might as well. So this is A, so it's going to be 3 squared plus 4 squared is equal to 6 squared. And we don't really know what it is yet. Oh, actually we can't say equals, my bad. We don't really know. We don't know if this is this is greater than, or this is greater than, or if they're equal to each other. So I know 3 squared is going to be 9. I know 4 squared is going to be 16, question mark. And then 6 squared is 36. So 9 plus 16 is going to be 25. So 25 is less than, this is a less than symbol. So this is less than symbol, is less than 36. So this is an obtuse triangle. Obtuse.